Hey math kids, today we're going to talk about adding and subtracting Maclaurin series. So if we start with sine of x and cosine of x and we need to add those together, you just treat it like polynomials where you're just going to combine like terms. And so right here they actually have no like terms in common. So I'm just going to write them with the smallest powers to the greatest powers, because that's typically how we write Maclaurin series. So we have a 1, then add an x, and we subtract x squared over 2 factorial, and we subtract this, and we add x to the 4th, we add x to the 5th, we subtract x to the 6th, subtract x to the 7th. And it's that simple. We just need to combine like terms if we happen to have like terms. And so now we're just going to move on to this subtraction problem that we have over here. Okay. So what I need to do first on this one, it's not as straightforward, but I need to find an expression for sine of x squared. So I'm going to change all the x's to x squareds. So x squared to the 3rd is going to give us 6. X squared to the 5th is going to give us x to the 10. And then this is going to be x to the 14. Okay. Now cosine of 3x, we're going to get 3x quantity squared, which that's going to give us, let me make this smaller, 9x squared. And x to the 4th, we're going to think of that as 3x to the 4th. And 3 to the 4th is 81 x to the 4th. So let's erase that. And then 3 to the 6th power. I'm going to use a calculator for that. 3 to the 6th. 729. So we did 3x to the 6th, and it turned out like that. Now, another thing that I'm going to do is I'm going to change all the signs on the cosine because it's subtraction. So it's like I'm distributing a negative to all these. So negative, positive, negative, positive, and this next one would be negative. Okay, so now we can do what we did on the first one. So we have, we just have this negative 1, and then our x squared terms can combine. And so 2 factorial is just 2. And so we can think of this like 2 over 2. So we have 2x squared, 9x squared, so that's 11x squared over 2. Now, let's see, x to the 4th, we're going to get 4 factorial is 4, 3, 2, 1, and 81 can be seen as 3 to the 4th. So if we cancel one of those 3's, that's 3 to the 3rd. So it's going to be 27x to the 4th. This was a subtraction sign on top. And then 4 times 2 times 1 is going to be 8. Okay, so we used up that. Now we have 2x to the 6th. So what I want to do first is figure out what the bottom is. So 6, 5, 4, 3, 2, 1. and then 729 was 3 to the 6th power. And so we can start off by doing 3 and getting rid of one of those. But also 6 is 3 times 2, so we can get rid of another one. So now it's 3 to the 4th, and this leaves a 2. And 3 to the 4th is 81, so I'm going to rewrite this. 81 x to the 6. And then on the bottom we have 20 times 4, so that's 80. Okay, so all of that was used up, but now we need to combine it with this. And so this bottom is 3 times 2 times 1, and so that's a 6. And so we subtract x to the 6 over 6. Now, we want to find common denominators. So this is going to be 2 times 40. This is 2 times 3. So this one needs a 3, and this one needs a 40. Okay, let's just double check that that works out. Oops. And so that's going to be 80 times, oh, it will, it's 240. I don't know why I wasn't thinking. Okay, so the bottom is 240 for both of them. We have an x to the 6 for both of them. And then if we multiply this and then subtract 40, what do we get? We're going to get 81 times 3, and then subtract 40. We end up with 203. Alright, that took a little bit of time. So we use that. 203 x to the 6 over 240. And then we could continue. We don't really have our stuff down here, so it's hard to know if we have a, we will eventually get an x to the 10, because these are just going up by 2. But this is as far as we took it out, so we're just going to stop there and say that this is equal to this. If you need additional help, please come to Math Lab. Until then, calculator.